one. Okay, it's official. We are starting.
I don't care. I said it earlier.
All right. So yesterday we talked about functions, right? We started that topic, that conversation, and like I said, they're very, very important. Most of what you're going to be dealing with from now on are functions. There will be in Algebra 1, everything we've been dealing with has been functions, basically. Straight lines, parabolas, you know, for some of you, you've done square root ones, they're all functions. In Algebra 2, you'll do some circles and ellipses. In geometry, you'll do lots of different shapes. But notice any shape that has it's a closed shape, like a circle, or a triangle, or a square, or a rectangle, or a polygon, basically. Any kind of a polygon would not be a function, right? When it's put on a graph, because there would always be a place where there's two y's for an x. So functions are often, they're not always never-ending, but they're often never-ending. And the thing that I love about functions, or the thing that I think that's so important and so wonderful about math, is that we can use math to model what is actually happening. I'll just wait for Oliver. I'm sorry. We can use math to model real things that happen in the universe, right? Great scientists, Einstein and others, have had these amazing skills and talents to take things that they see in the world, right? Throwing a ball, right? Beautiful, beautiful art. Oh, lovely catch. Lovely throw.
Gary
Right?
catch.
So, nice throw again.
Gary, I can actually. Gary.
I think let's see. Oh yeah. Okay, so watch. So guys, as this goes around, watch the arc.
Whoa, amazing work there.
Watch the arc. Okay, sometimes the arc gets interrupted.
Yeah, oh,
All right, not to me. To me.
Oh, come on.
To me.
Gary.
Thank you. So there are things in life. There's things in life on this planet, the way we live, right? There's games we play. We throw something up in the air and we have kind of an idea of where it's going to come down, right? We see things like that. We see boats traveling through the water. We see stars moving in the sky. We see all sorts of things happening. We see the sun moving, it looks like the sun moving around the earth, right? Or maybe the earth moving around the sun. Or maybe other planets moving around us. Or maybe us moving around other places, whatever. Or our galaxy moving around a different galaxy. There's all this stuff happening in this universe, omniverse, amazing, thing that we live, that we're a part of. And it's phenomenal that scientists can determine there are a certain number of billions. I think they're guessing right now there's 190 billion galaxies in the universe. What?
Maybe there's even more big bangs.
Well, at least for now, that's kind of what they're predicting. And who knows? I don't know. And then they're predicting that there's about 190 billion stars in our galaxy. And, I don't know how they get these figures. But, and then Einstein comes up with E equals mc squared. He's modeling something he sees in real life. He's modeling it with what's called a function. All right? It's something that's fairly predictable that allows us to determine something about what we're seeing. There's no way we would have ever been able to land a man on the moon if we didn't understand math. If we weren't able to model the concept of gravity and the forces between different planets and different objects, right? The mass of an object There's no way we'd land somebody on the moon unless we understood that. We would have completely crashed, right? So we had to calculate, to the nth degree, exactly what was going to happen. What are the forces acting on that spaceship when it was getting closer to the moon and when it was starting to land? So much about math. It's all about modeling, and it's about modeling with functions. So all these equations that we've been throwing at you are the beginnings of these functions. They're fairly easy functions, but it's pretty awesome stuff in my opinion. I think it's pretty amazing. Now, if you think about a function, I sort of think of it sort of like a machine, right? And so, I don't know, let's see here. I have a very funny story, but I think I'll wait on that one. It was rather embarrassing.
Yeah, now you have to tell us.
All right.
Now you have to tell us, Gary.
So this is,
All of
that's the
machine.
input, right? And we'll just make this the output.
Oh my gosh, I haven't seen this since
Um,
elementary school.
I haven't seen that since elementary school either.
What?
I haven't seen this graph thing since elementary school.
I have to put that in.
Okay.
And like you
So
put in
this
a
is the
number and
input.
another number comes out.
This is the input, and this is the output.
And then the formula goes.
You with me? Yeah, exactly. The formula goes in the middle. So I have f of x is equal to, I don't know, 2x minus 7. Okay? And then I know that when I put in an x here, when I put my input is my x. That's my x, right? And my output, that's my y. Right? Makes sense. And so I know when I put in a specific input, I know it's only going to have one possible output down here. But in order to get to the output, it's got to go through this little machine, and it gets manipulated. I multiply that number by 2, and then I subtract 7. And then boom, I've got my thing, right? My answer. Okay? And then, so a function is sort of like that. It's sort of like this machine. It's like this thing that processes the input and turns it into an output, right? Now, what we're going to talk about today is domain and range. You already know that domain is all the possible x's, right? And range is all the possible y's. Now, if I were going to graph something, let's just start to see how you would write domain and range and determine those. Can I erase this? Okay.
I missed that machine.
Yes, remind me to tell you that story another time.
Just tell us the story, Gary.
No, thanks. I can't do it on the video.
Why
Yeah,
not?
you can.
Definitely can't do it on the video. Okay, so let's say we have a line and it's got arrows going in both directions. We can have domain and range. Okay, well, first of all, let me just write domain is all the possible x's, and range is all the possible y's. Okay? You can have a domain and range of functions, and you can have a domain and a range of a non-function function, of a relation, right? Doesn't have to be a function to have a domain and range, right? A circle still will have a domain and range, even though it's not a function, okay? So, all right, so as we look at this, now my question is, what are all the possible x's with this particular graph? Say it again? Okay, so I think London's noticing, well, definitely there's x's here, but this is going on forever and ever. So no matter where I go this way, as far as I want, forever and ever, there's always going to be a point somewhere, a y for that point, right? And same thing this way, forever and ever and ever and ever and ever, right? So there's always going to be, so he said infinite. The way you would say that is the domain, and I'm fine on the homework if you just put D for domain and then colon, and then you can say x equals all real numbers. Okay? I have to say real because there are also unreal numbers. There are imaginary numbers that don't exist that mathematicians use, and they can be very useful, ironically, right? So they are all real numbers. There is an abbreviation for that. If you use a capital R cursive like that, that is also another way to say all real numbers.
You guys never learned how to do capital
I
letters?
did. but
So
my
then
third grade
write
teacher-
this, all real numbers.
He was all like, okay, Luca and Jacob, you don't get to write any cursive.
I never got to.
They're really fun. They're really fun to do. So now, so everybody agrees, right? Fist of five, you get that, right? Domain is all real numbers. There's nothing that x cannot be. Now what about y? Same thing, right? Same thing. So for the range, y is also all real numbers. Okay? That's awesome. Okay. Now, this is a line. A line goes on forever and ever in both directions. What if I had a line segment? And just so I know, so we'll say this is 10, and we'll say this is -9, okay? Something like that. And we got a point at the end, okay? This is a line segment. Now suddenly I have a different scenario, don't I? So I would have to say, what are the possible x's? I have a solid dot here, right? That means it includes this point right here, the 10. I have a solid dot here, it includes this point too. So what would I say? So, Mira. Yeah, basically, so in this case, now, let me get rid of this now since we've got a different one. We could say x, and no longer is it going to be equal to, x is greater than -9, greater than or equal to -9, right? You can see that? X is greater than, it's bigger than, going this way, or equal to, because it can also equal that dot, -9, and then you could say and x is less than or equal to 10. Now, there's one other way you could write that, which is a little easier, in my opinion, but some of you may find that easier. But this is how I would write it. I would put the x, I think if this is my two boundaries, right? I'm going to put -9 on the left. I'm going to put 10 on the right. I'm going to put x in the middle, because x is all the stuff in the middle, right? I always have my lower one to the left, my higher one to the right. X is in the middle. And I know x is always going to be bigger than the lower number. And in this case, it's also equal to, so I put that equal sign. And I know x is always going to be smaller than the bigger number. And I'll put that. So that's another way. I'm more inclined to do that. That's very common in algebra, okay? Does that make sense? Do you guys understand?
Yeah.
Did I lose you?
What about, is the range the same way?
Okay, so the range, yeah, the range is the same way. So we got to figure out what this is. So that's -5, and this is 8. Right, I'm making them up. So I would say, in this case, what would I say? So for my range, let me give myself a little more space since these are.
So the range would be y is.
So I'm going to put my y in the middle, and I'm going to use my lowest one, -5, and I'm going to do my top one, which is 8. I'm going to put my y in the middle,
Y is greater than or equal to negative.
greater than or equal to -5, and and less than or equal to 8. Now, as long as you're always putting them this way, these things are all these less than greater. They're actually less than or equal signs. They're always pointing to the left, right? Always. So when you're using this three-term model, just make them always to the left. It works. You always, as long as you always have the smaller number on the left and the bigger number on the right, and the variable in the middle. Get it? Make sense?
Yeah.
Okay. Now, what if I had done this though? What if I had put an open circle here?
Oh, then it would just be it would just be greater than.
So yeah, this is no longer including the 10, right? So up here, well, where am I? What am I doing? Yes, so for the domain, right? For the domain, it no longer includes 10. It goes up to 10. 10 is like a boundary point, but it doesn't include 10. It goes up to it, but doesn't include. So I can't say less than or equal to, I have to just say less than. Does that make sense?
Yeah.
Make sense? What about the y? What would I do?
Then you would just do less than 8.
Yeah, so the less than 8. It doesn't include 8. It just has to be less than.
Oh, Gary,
Yes.
what if can you have like a dot and one, like a ray?
Yes, you can have array too. So let's do that. That's a great idea. Brilliant. All right. So, probably be easier just write a new graph. Okay. Where am I? Okay. So here we go. X and Y. Well, okay. So here we go. We got array. Let's say this is at -9, and with this here, starts there, and it goes there, and it goes forever. Array, remember, it starts at a single point. It doesn't go beyond that point that way, but it goes forever this way, right? Just remember those? You guys all learned arrays?
Yeah.
Okay, great. So, what's my domain? This is actually really easy.
So would it be x is greater than or equal to -9?
Bullseye, that's it. X is greater than or equal to -9.
That
All
is-
done, that's it. Okay? What about your range?
X
All
is
real
greater than or
numbers.
equal to -6.
Well, this is -6, my dear.
X is greater than or equal to -6.
God. What's wrong with you? Okay, yeah, X is greater than or equal to -6. Okay. Okay, right? So if this to 5, am I losing anybody or are you getting it? Making sense? Okay, all right. Okay, so now
Oh yeah,
let's,
that's my Gary.
I
What?
don't have to wait till 9 to do my work.
You didn't post it at 9.
Yeah, but I got home at 9 and I didn't work on
Okay.
the half before because the video wasn't.
let's do,
Even though I didn't use the video.
let's do a parabola, okay? A parabola. All right.
Oh, Gary.
I should just write my notes.
Okay, this is my y, this is my x. So now I want to know what is my domain and what is my range. What's my domain first?
Well, there are no arrows. So that is 32.
Oh.
So a lot of times people,
snap.
a lot of times, yes.
God, Gary.
Ah!
I thought you were the
Okay.
math teacher.
All right. A lot of times with parabolas, you don't see the arrows very often in graphs for some reason. They should be, but you don't see them as often. I don't know why. But yes, we'll have to just. I'm assuming unless there's a dot. You know what I'm saying?
It just goes on forever.
I'm just assuming it goes on forever. Okay. If there's a dot, then it stops. But okay, so going on forever. So what's the domain?
Okay. So would it be like both
With
the
all
X's?
real numbers.
No,
No, because it'd be like, it'd be all
So,
real numbers. and
remember,
all negative.
domain is all the possible x's. Is this possible?
Yeah.
Yes.
Yeah. Is this possible?
Yes.
Yeah.
Yes. Is this possible?
Yeah.
Is this possible?
Yes.
Is
That's
this
why I
possible?
said all
Yes,
real
it is,
numbers,
because
It's
it
like
goes,
all
it
real
goes on
numbers
forever.
above
It goes on
it.
forever.
Yeah.
It's going to
Oh,
take
yeah.
a while,
Oh,
right?
But it-
It's going to take a
eventually
while
get
because
there.
it's going kind of slowly because it's going mostly up, but it's always getting bigger.
So is it all real?
Therefore, it's all real numbers. Exactly. So x is all real numbers. Okay. What about y? All real numbers,
X
right?
is, no. No. X is greater than -5. Y is greater than -6.
1, 2, 3, 4, 5. You don't like -6, do you? That's -6, girl. Okay.
Don't
Alright.
ex-
So what? Say it again. What was it?
X is, Y is greater than or equal to.
Yeah. So y is greater than or equal to -6. Beautiful. Excellent. Okay. We're basically that's basically all you need. But
She tried.
what if I did? Let's just try to. Let's put stuff that's sort of a little more scary looking. that you might see.
Want to do that, Jerry?
There's lots of other shapes that are functions that other than what we're studying in Algebra 1, right? There are these, and then there are, these, and then there are these, and there are all sorts of things, right? And so this is the homework, right? So let's say we did this. What a lovely shape. Oh yeah.
Oh, that's a sexy grape.
Okay, and then this is 3, and this is -5, and this is 1, 2, 3, 4, -4, and this is 1, 2, 3, 4, 5, 6. Okay, 6. Okay, what is my domain? What's my domain?
Okay, talk about that being around here.
Domain is, x is greater than or equal to -5.
Phil, who's talking? Sorry. Say it again. X is
Greater than or equal to -5, and x is less than or equal to
yeah.
3.
And in my case, I would probably say I would just do it like this. I would just, like I say, start my left boundary -5. My right boundary is 3. My x is somewhere in all of the stuff in the middle, and I know x is bigger than, and it includes -5, and x is littler than, but also includes 3. That's what I would say. Make sense? You see that? All right, and then what's my range?
Y is
So I'm going to
greater
put
than or equal to -4.
so -4 and 6, right?
Yeah.
My x, excuse me, my y in the middle, and then I say greater than or equal to, and less than or equal to, right? Make sense? Now one last thing I'll just mention. I think everything is self-explanatory. There is sometimes you might get something like this. There is one like this that can scare people or confuse people. Oh no, I think you'll be fine with that one. Yeah, you'll be fine. I don't think you'll have too much trouble with these. But I was going to say, there are different ways of writing the domain and the range. It's called set notation. Sometimes people will write things like this. They'll use set notation. I'm not asking you to do this, because the reason why is so many teachers have their own method that they prefer. And if I teach you 3 different methods, it's just confusing, right? Better if you get a teacher that says, oh, you've got to use these things and these things, then that's great. But if other teachers will say you got to do it this way, you got to go the set of all x's such that, and you can put the colon for such that x is greater than 3, and so you might see it like that, or you might see it like this. The same thing, set of all x's such that x is greater than 3. All right? Then you'll see sometimes x is greater than 3. Whatever. You might see, things like this. I don't even worry about all this, because the main thing is you understand what you're writing. Just write it the way I've been showing you, right? For now, because that's the part. If you understand that part, you can learn any of these methods, and it's no big deal at all. Okay? So that's basically it. I think I'm going to end the lecture. And fist to 5, though, everybody pretty much understand it? Awesome. You got it. You'll be fine. As you practice it, you'll get better.